Stefan. So it's my pleasure being here. As I introduced, my name is Anita Graser. You probably know me from the QGIS project and from GIS.StackExchange, where I'm trying to give support for GIS questions. Today I want to talk to you about a research project that I'm currently working on, which is dealing with pedestrian routing. So from the fun with rally cars, we are now back down to earth. We have to walk on our own active mobility. And we talk a bit about pedestrian routing and navigation. What's the point of departure for this project? We've wanted to calculate realistic pedestrian routes. We wanted to compute a landmark navigation instructions. I will get into detail what that means and how they look like. And we wanted to do all this with commonly available data, which basically means we are doing it with OpenStreetMap, rather than any national data set which we might use together with local point of interest data, because that just doesn't scale. And this is a European project, so you wanted that your partners can also use it in Germany or in other countries of the EU. For a short outline, I will be talking first about the issue of pedestrian routing graphs, which are not as straightforward as one might think. Then I will be talking about the whole issue of extracting landmarks from OpenStreetMap. So how can you get to the point where you can say, walk straight ahead and then turn left after the church? How do you find the church or whatever place it is that you want to use in your navigation instructions? And then, of course, the whole thing of algorithmically constructing the navigation instructions. So first of all, the pedestrian routing graph. It's a mess. We cannot put it in any other way in OpenStreetMap. You have places where the mappers decided to put the sidewalks as separate links. Then you can extract those sidewalks and you can theoretically route on those. In other places, the mappers didn't do that, and instead they would mark a road with a tag that says this road also has a sidewalk, but there is no separate geometry for that sidewalk. So if you wanted to make a pedestrian routing which sticks to sidewalks, you have to first extract those sidewalks, like we were trying to do here. So we have the information for this road. There's a sidewalk on both sides, so we can draw the sidewalk in a pre-processing step. And because we are not mean, we also want the pedestrian to be able to go from one side of the road to the other side, for example, if there's a shop that they want to go to. So we also introduced those connections between the different sides of the road, so that you have a way to cross the street. That's the case for the normal roads. And then we have the case of wonderful big pedestrian squares. And I will get into detail about this topic on the next slides. Those are really interesting. Currently, the routes that you get if you try to route over squares, they are ridiculous and nonsensical. I mean, they just follow the outline of the square, because that's what the simple pre-processing scripts do. They take all the road links, and then they take the squares, they use the outline of the square, insert it into the routing graph and say, yay, we are done. And then the pedestrian has to walk along the outside of Rockefeller Plaza to get to the other side of the square. This also leads to effects where the algorithm completely avoids the square because the route gets so long that it actually thinks it can get to the destination on other routes much faster. So I've been looking as part of this work at different algorithms for pre-processing the OpenStreetMap data, those squares, to get a better pedestrian routing graph to work with. And from the left to the right, you can see different approaches that I tried. So the first three are something that you can find quite readily in the GIS literature. You can extract a medial axis or a straight skeleton. These are both very well described. A bit hard to generate. Very simple to generate are different grids. It can be a square grid, you can make a triangle grids or hexagonal grids. But what all these approaches have in common is that they do not result in a route that I would take if I was a pedestrian. If I'm a pedestrian and there's an open square in front of me and I want to go from one side to the other, I will choose the most direct path or something very close to it. So it would make no sense for me to see a route which goes like this with this corner in it, or these curvy routes. So what I ended up selecting is something that is very well known from game development and from pedestrian simulations. It's called a visibility graph. And in the visibility graph, you connect all the nodes of the polygon outline. You create those connections, and then you remove connections which are blocked, for example, by a building that's in the middle of the square. That's actually a very nice example in the center of Vienna, Stephansplatz. And it shows very well that there's a lot of links that you have to insert for this solution. Because you generate the complete graph, then you remove all the links which are partially outside the polygon, either because they are just at the borders, or because they are crossing something that's inside the square. And the remaining ones you could integrate in the routing graph, and it works. This is an experiment I did in QGIS with the network analysis library that is built in QGIS for routing purposes. And you can see here, I'm starting the route on the regular routing graph, and then I start to enter the square, and it continues along the gray lines, which are the visibility graph of these squares. If you're interested to learn more about this topic, this paper has already been published and it's open access, so you can read about the whole story there again. Because the second topic I want to get to is the topic of landmarks. How can I get to the point where I can say turn left after the church? There are so many features in OpenStreetMap that are potential landmarks. And for the first round of implementations that I wanted to try, I just imported the whole OpenStreetMap dump for Vienna in my example into PostGIS with OGR to OGR. And then I constructed landmark views. So these views are they contain all the potential landmarks that I've identified. And how are they identified? With quite huge queries, because I have to go through lots of different keys and tags to see everything that could be a potential landmark. What comes in very handy is the HStore support in PostGIS, because you can access all those tags that OGR puts into the other tags by default. If you have questions about how this works, we can go into detail. Of course, you can control that not everything is thrown into the other tags already on import, but I decided against that and just use the default settings. That's why I have to do so much other tag work at this point in time. So I do this for the points as well as for the polygons, because many things are mapped in different ways in OpenStreetMap. For example, if there's one building and this building is a shop, it's usually a polygon. But if the same shop is within a bigger building and this building contains multiple shops, then it might just be one point represented as a point. That's why you have to have both of these feature types as potential landmarks. Another step that is necessary, except for filtering, is also weighing, because some types of features are just more useful as a landmark. So I basically had a small expert workshop at a conference where I asked people which things are more useful as landmarks and which are less useful. And I generated a list, and I can now weigh, I use values from 0 to 100, the suitability of a certain candidate landmark. And I'm also constructing some more useful names from OpenStreetMap in the other part. So if both of these things are in place, the routing graph, and I have this database, these views full of potential landmarks, I can go ahead and try to generate landmark-based pedestrian instructions. I'm skipping here the whole topic of how to generate the route for the pedestrian. I can do the simple shortest route, or like our project partners do, they try to find the most suitable route for a pedestrian. So maybe not next to a big road with noisy cars, and instead go in the parallel road where there are nice trees and shade, and it's much more pleasurable to walk. I don't have time to go into that. But we then get this route and we try to describe it to the pedestrian so that they can follow the navigation instructions. And we have to find the most suitable landmarks to do that. So to generate navigation instructions, we have these basic steps in our algorithm. First, we take the whole route and we split it into episodes between so-called decision points. A decision point is when you have to change direction. You can also define a decision point at other places, but the most important decision point is when you have to change direction. Then at these decision points, you compute the turn instruction. So do you have to turn left? Do you have to turn right? Do you go straight ahead? Then you have to select the most suitable landmark. Then you try to compute if the landmark is before or after the decision point. And in the end, if you have computed all those things, you can create the routing description. What are the challenges when you try to do that? It already starts with the first point, with splitting into those episodes between decision points. Because what we found in the first run is that we get way too many decision points. It's like go 5 meters and then you turn left, and 5 meters and then you turn right. And the issue is shown here in this one example. You have this super short section of just a few meters, and the automatic algorithm thinks you have to turn twice because it's just above the threshold of this turning angle that you defined. And so it says first turn left and then immediately turn right again, even though it's completely useless for the pedestrian and they should just walk straight over this crossing. But it's mapped in OpenStreetMap that way, so how do we deal with that? And one idea is that you have another processing step on the route, which finds those really short elements and tries to replace them. So you take out this middle section, the really short one, replace it by the red point, and you connect the remaining points. And this way, this zigzag thing is gone. It also works for turning, as you see in the example B. And it also can work for more complex stuff like shown in C, where I define that you must not remove short sections if they are a zebra crossing. Because I want to keep the zebra crossing, I want to be able in the final instructions to tell people, use the zebra crossing there. So I must not remove that one. But I'm removing that horizontal line and this horizontal line. So in the end, you just go straight crossing on a zebra crossing. Then you have to compute turning instructions. That's rather simple. It's just a matter of taste. How many of these sections you have. You could just have straight left, right, or have it a bit more fine-grained like this. Also how wide the angle is for straight. There are discussions in dozens of papers what this angle alpha should be. But really, there is no right and wrong here. You can test it with your users if they have a certain preference, but it's just a parameter for the algorithm. Where it gets really interesting is the selection of landmarks. So I have here just 5 different papers over the last 15 years of how it has been done in the past. And there are really simple ones where you have building databases and you just select the named buildings that are within the buffer of the route. That can be done, that's simple. And then they have built on these results to find the most unique buildings. Like also here in Bonn, you have this example where churches are really close by. It would be confusing to say turn left after the church because here's a church and there's a church and where am I supposed to go now? So you might want to find the most unique buildings. Then there's an approach, which is the one which we are basically using, which is rule-based using categories. You saw that before in the view definition. There's the category shop, which is quite suitable. There's the category museum, which is great, or churches are better. And then there are other algorithms which have also been tried, up to neural networks, which are trained with social media data, for example. So if you remember, I have one view with points and one view with polygon landmarks, and from both of these views I select the 10 nearest points and the 10 nearest polygons. And then I'm weighing them with a formula, which looks a bit involved, but there is just a few parts in it. One important part is the distance between the decision point and the landmark, so obviously you want something that's close to the decision point. Simple. Then we have the suitability, so we want something that's really well visible, that can be distinguished as a landmark, so we have this category suitability. Then we decide, there's one option to consider the side of the landmark. In some papers they say that a landmark stands out more if it's on the same side that you're turning to. So if the instruction is turn right, you would be looking for a landmark that's on the right side, and if the instruction is to turn left, you would be looking for a landmark that's on the left side. You can use that or you can leave it out. Then you want the location of the landmark relative to the route. So is it before or after the decision point? Do you say turn left after the church, or do you say turn right before the supermarket? And where it gets really tricky is the visibility of the landmark. How can you make sure that the person can actually see the landmark when they get to the decision point? And really, with OpenStreetMap data alone, I haven't figured it out. I don't know for sure how you can ensure that you can actually see it. Of course, you can do some raycasting algorithms, and you can see, theoretically, is this visible, but there might be trees or something that you cannot see. Also, there's the issue with the point landmarks. They are inside polygons. So simple raycasting would say you cannot see the point because it's inside a polygon. So some colleagues went ahead and made buffers around the points and then checked if you could see the buffers from outside. But how big is the buffer supposed to be? So it's really guesstimating with the visibility. And I think we would need additional data to really make sure that something is visible. We also encountered the issue like, okay, great, there's really close by a hotel. That should be visible. But then it turns out when the people tried the navigation instructions that it was the back side of the hotel. It didn't look like anything from the back side. If they would have approached it from the front, it would have been clear that's the hotel, blah, blah, blah. But since they were coming to it from the behind, they had no notion that this weird building was a hotel, so we failed again, unfortunately. If you have good ideas how to determine which side of a polygon is the front, let me hear it. So to wrap it up, the other parts that we need. We also need to prepare the preposition. So do you turn before, after, or at a point? For the points, it's simple. You can just calculate the angle with the route. For the polygons, it's a bit trickier because, as you can see, I could select any of the corner points and they would give sometimes confusing results because they end up in different categories. So I decided to use the centroid, which works well for smaller polygons. If it's a really big building, on the other hand, the polygon, the centroid might not be a good representation of the polygon and the preposition might be a bit odd. So that's another point where you can think more about what we could do. And then we can string this all up. We can make a list of which edge do you have to walk on, what's the turn instruction, at which landmark, and what's the preposition. And you list those things up, and someone who's good in user interface design then has to figure out how to communicate this stuff to the end user. Because that wasn't my part of the project, I basically have this output in QGIS, where it accesses all the data in the PostGIS database, does the routing, and computes these instructions, which I detailed before. Why did I use QGIS? Obviously because I wanted to debug the results, and that's the best way I know of how to see if it shows a landmark that is obvious also for a human observer, and what's the and try to estimate if the turning instructions were computed correctly. I was too lazy to implement the rubber bands to follow exactly the route, so you have to imagine that the rubber band is here. Please. If you saw the list before of those instructions, of course it makes sense to have a standard format of how to exchange those instructions with other parties. We've been working on this format for quite a long time, and that's why we have published it online. We haven't found anything similar so far. This covers not only the pedestrian routing part and the navigation instructions, it also has sections for public transport routes and how to communicate that to other people. And we would be very happy if other people would be interested in using this format as well. It's on GitHub, and if you need to know any details, just contact me about it. What you've seen so far is the prototype that I've implemented in QGIS. In future work, we are planning to also investigate the issue of linear landmarks. So besides points, polygons, we could also look at lines. For example, if a river is modeled as a line, or railways could be also landmarks because you can easily follow them. Everything has been implemented in Python as a prototype first, and this will now be migrated to a web service which can be used together with an app. And we are also planning to field test it in Vienna and Magdeburg next summer. If you have any questions about any of those, please get in contact. Also, if you have answers to the questions that I posed during the presentation, I would love to hear them. Thank you.
Thank you very much, Anita. There must be some questions about this interesting work. Anyone?
Hi, I'm Johan, working on OSRM. Pedestrian routing on OSRM sucks. Like, as you've shown with the squares, it's terrible. I have a question around the squares. So in one of the examples, you had two squares that were neighboring each other.
Yeah.
How do you select the intersection between these? Like where to put the point over how to cross between them? And how do you handle structures inside of squares?
Those are some very good questions. And in the case of these two neighboring squares, I was in the lucky position that someone had also mapped cheating lines over the squares so that ordinary pedestrian routers can cross the square. So there were nodes here which I didn't have to insert, but I could just connect to. Another colleague at the FOSS4G in Salzburg this year presented that actually you first have to do the step of merging those neighboring polygons and then compute the visibility graph for the merged polygon instead of separately, which I skipped here because I didn't stumble on the issue since someone had already solved that. And the other thing with the obstacles on the square is, in this case, it's again simple because the square was modeled with this hole in the middle already. So the Stephansdom was cut out of the square. If that's not modeled in that way, you have to first subtract it from the polygon to really just get the open area and be able to compute the visibility graph correctly.
What do you do if there are no good landmarks in the decision points? Do you change the route or anything?
That would be one option. That's a very good question. Of course, we are using an area of analysis which has a lot of landmarks because we are more interested in finding a good one amongst a lot of landmarks. If there's really no landmark, the fallback is to use the standard navigation instructions, turn left after 300 meters. There would be one intermediate thing, like turn left at the third crossing. But I thought about it, and counting those crossings, and everyone counts them differently, is pretty challenging as well. So in case there are no landmarks anywhere to be seen, I think I would just resort to the simple approach of telling them to turn left after a certain distance. But there are also in the literature, you find many other algorithms which don't take the route as a given, And instead, they might implement a route that is most easy to describe with the landmarks that you know. So you go first to this landmark and then to the next landmark, and then it's just a short route to your destination. But that's a completely different algorithm than the one we are working with here.
Did you think about text mining the name of the landmark? Because like McDonald's, everyone's going to recognize that. But if you say some local bakery that no one's heard of.
You mean to text mine out of the street map data? No, to determine which of the landmarks would be well known by the public. That's a good point. We haven't covered that in our project so far, but it's a completely valid objection. It also depends a lot on who are your expected end users. Is it a touristic application where you cannot use any local brands probably? Or is it for the locals who know all the little coffee chains that are specific for a certain city? It's a huge problem to do it for tourists, I think, who are not aware of most of the stuff that's around.
Can you wrap up once again the selection of landmarks you have chosen this algorithm?
The formula?
Yeah.
Mm-hmm. Here.
So what counts of a landmark? It's based on tags out of OpenStreetMap and some geometric. I mean, what are the non-geometric properties of a landmark in your algorithm?
The non-geometric one
Yes.
is the category, which tells you if it's a restaurant or if it's a church.
This one.
This one. This is not geometric.
And
Yeah.
everything else is geometric.
The rest is geometric.
I see. Okay.
Yeah.
Because out of ranking features of OpenStreetMap, I know that you could take Wikipedia, of course, and rank higher this kind of landmarks which have an entry in Wikipedia or something.
Yeah, that would go into the direction of the more touristic ones or historically important buildings. Mm-hmm. You could give them an extra bonus, but in many places you won't have anything that has a Wikipedia entry, so you have to fall back on other stuff.
I see. And from the side of the routes, can you show the slide where you pre-process the OpenStreetMap ways and cut out the pedestrian
This one?
routes? Yes. So you say you have taken sidewalks not on roads, but also roads. But this is showing a road without a sidewalk.
The blue ones are the sidewalks and the connections between sidewalks, and the black one is the original road.
And
We would only do the routing on the blue ones.
And what about all those roads which have no assigned sidewalks?
If there is no sidewalk, you have to route on the road, because people can walk along the road. It's just not very comfortable.
I assume that many OpenStreetMap roads have sidewalks, but
Yes,
are
they
not
do.
tagged as such.
That depends a lot on the location you're looking at. In Vienna, the mappers are very careful, and there's a lot of sidewalks. Of course, if you're applying this to a location where you have to expect that most sidewalks are missing, you probably default to the assumption that there is a sidewalk on both sides.
So that's what you have done. You really are looking on assigned sidewalks,
Yes.
either on its own or as allowed and things like this. So, and how do you consider crosswalks on the streets? Is there a crosswalk along the road?
So here you have a crossing, and these would be the regular crosswalks that you could insert by default, and then we have all these extras for crossing the road as well.
So you don't distinguish between the regular crossroads probably entered here, and so you add additional ones.
It would look different if there was like a zebra crossing, which is mapped as a point in OpenStreetMap. Then it would look different. But this crossing doesn't have any of those things. It's just
I see.
a regular one.
Yeah. And for the road description, I realized that in OpenStreetMap, you often have to make two ways, which are just right one after the other. So you would like to merge it before you generate your route description. So you have to merge it for getting a more smooth description, because you have some just technical cut of two ways, which are two ways, but in fact it's one street name, one description.
That makes no difference, because in our definition of a decision point, it's only a decision point if there is a certain change of direction involved. So if it's just split here, the link, it doesn't end up in the list of decision points anyway. So that doesn't influence the results.
Okay, so you have never something like change from Bahnhofstraße to Bahnhofstraße just because they are subsequent.
No, that doesn't happen in the decision point selection process.
I see.
Have you looked into traveling salesman problem optimization algorithms when applied to this? You would have to calculate distances between all pairs of landmarks, but you could get really optimized routes this way.
How do the landmarks play into this traveling salesman thing?
Well, suppose you want to go through all the landmarks in the city.
Okay, so like a tour for a tourist who wants to see certain landmarks.
Or a set as you have 2 hours and you want to visit as many landmarks as possible. If you choose the best landmark in each point to go next, then this is called a greedy algorithm, and it's usually 50% longer than the optimal ones. So you get to look into this.
That's also a very interesting idea, and I think there are some tourism-focused projects who do this tour planning for a given time or to visit some certain locations. But that's a completely different focus than our work, where we just try to describe the given route as best as we can. But it's super interesting application as well. You can also imagine, I want to spend an hour of time and just show me the city. What can I see? Ask this to an algorithm is also very challenging.
Actually, in Switzerland, you can try out my prototype. It's called poitour.ch, and it does exactly something like this. And it's just a prototype because we had very different challenges. So when you say I'd like to visit say fountains or viewpoints, then what is the mix between viewpoints and fountains? And so the algorithm didn't take a nice mix and suggested to you 10 fountains and 1 viewpoint or something. It's really difficult to have such an answer, but it's a showcase, poitour.ch, and not yet so, but a different problem actually as this one. Any other questions? So, thank you very much, Anita.